Let me explain the do now.
So let's understand the problem. There is a box sitting at rest. The box is 4 kilogram. This box is 4 kilogram. So this is sitting at rest. We want to move this box from location A to location B. And the distance between location A and location B is 10 meters. I want you to first do the free body diagram. Number 1. Number 2, I want you to find out the work done on this box by each and every force. Okay, so how many forces acting on it? It looks like 4 forces acting on it. Tension force, friction force, the gravitational force, and the normal force. So let's do the first step, and that is free body diagram. So free body diagram right here. So Fg. So what is Fg? Fg is mg. So m is 4, and g is 9.8 meter per second square. So Fg is 39.2 Newton, and normal force is exactly 39.2 Newton. Why is that? Because there is a tension force, but that tension force is not upward direction. So normal force is going to be equal in magnitude but opposite in direction with the gravitational force. Now let's take a look at the other force. So we have a blue force, and then we're going to call it pulling force or tension force, because Mr. Barry is pulling the box using a rope. So whenever you use a rope to pull anything, there is a tension in the rope, so you're going to call it tension force. Excellent. Now there is other force, and we're going to call it and that is smaller. You're going to call it 30 Newton. So make sure this arrow is smaller than the other arrow. So this is 30 Newton. F friction is 30 Newton. Now we're going to find how much work done by tension force, the normal force, the friction force, and the gravitational force, and we're going to do it like this. However, the green vector represents the direction of the motion. So the object is moved this direction. So this is the direction of the green vector. Green vector is the displacement vector. What does that mean? That means the box is moving at the direction of the tension force, not other force. Box is not moving at the direction of the normal force. Box is not moving at the direction of the friction force. Box is not moving at the direction of the gravitational force. Box is only moving at the direction of the tension force. Keep that in mind. That's very important. So we're going to have a scenario. We're going to have a vectors. Now number 3, we're going to have the equation. All right, and we're going to have the answer. Okay, so scenario 1. Let's see the vectors, the orientation of the vectors. Scenario 1. Scenario 1 is going to be scenario 1 work done by let's not vectors. Scenario 1 work done by tension force. So work done by tension force. Okay. So the force is the tension force is this direction. Okay, and this is the tension force, and the displacement vector is actually at the same direction. So how can we translate it into math? What is the relation between these two? Relation between these two is parallel. So what is the angle between these two? 0 degree. So you're gonna write work done. So you're going to write work by tension force is equal to FD cosine 0 degree. Why is 0 degree? Is because the relation between this blue and green is 0 degree. So F is 50 D is 10, and cosine 0 degree is 1. So 500. Work done by tension force is 500 joule. Okay, 500 joules. So positive work is done. So positive work is done. Okay, type of work. Number two. Now we're going to do the normal force. This one going to be normal force. So you're going to do the normal force. Normal force. Okay, normal force. What is the direction of the normal force? The direction of the normal force is perpendicular. As you see, the direction of the normal force is perpendicular. Let's make it blue. Alright, so you're going to put the direction of the normal force perpendicular. You're going to call Fn. What is the direction of the displacement? Direction of the displacement is not at the direction of the normal force. In fact, the relation between 90 degree, when the relation is 90 degrees, zero work is done. Why zero work is done? Is because FD cosine theta is 90 degree between these two. So F is of course 39.2, D is 10, and cosine 90 degree is 0. So how much work is done by normal force? Only 0 joule of work done by normal force. Type of work, none. Alright, now 3, we're going to do friction. We're going to do the work done by friction in the box. Okay, so the friction, what is the orange? So what is the direction of the friction? Direction of the friction is to the west. Now, what is the direction of the motion? Direction of the motion is to the east. So this one is force of friction, and this one is the displacement. So what is the relation between these two? 180 degree. So we're going to report what we see. So negative work is done because this is cosine 180 degree. So work done by friction is F is how much? F is this time is 30, D is 10, and cosine 180 is negative 1. So work done by friction is negative 300. So what type of work is done? Negative work is done. Okay, excellent. Now total work, we're gonna write total work. Total work is 500 joule, 0 joule, 0 joule, and this one is negative 200 joule actually. Negative 200 joule. Alright, now we're going to finally do the force, scenario number 4. Scenario number 4 is, as you see, is gravity. Work done by gravity. So let's write work done by gravity. So work done by gravity is what? Let's see. This is the gravitational force. This is the gravitational force acting on the box, and this is the displacement. This is the displacement vector. So the relationship between these two is also 90 degrees. So how much work is done? 0 work is done. Work is FD cosine 90 degree, or you can write 270 degree. No one can stop you if you want to write 270 degrees. So F is 39.2, D is 10, and cosine 90 degree is 0. So work done by gravity is 0 joule. So none and 0 joule. Now we're gonna find the net work. So finally we're gonna find the net work. Net work is work done by tension force plus work done by normal force plus work done by friction force plus work done by gravity, and all together if you add them up, you're gonna see this one is 300, I believe. This one is 300. So this one is 300. So if you add them up all together, you're gonna see total work done is 200 joules.
Science Lab to fall in love with math and science, especially programming.